All right, this is 6.3, video 2. I don't know why that's there. We're going to be converting back to logarithms from exponentials. So in the first video, we learned all about logarithms. We learned to write them as exponentials to help solve them. Now we're going to practice our notation just a little bit. We're going to start with an exponential. We're going to solve it, and then we're going to rewrite that as a logarithm. All right, so the first one says 2 to what power is 32? And the answer is 5. 2 to the 5th is 32. 32 equals 2 to the 5th. And you can just, if you don't know those off the top of your head because you haven't taught math for 15 years, you can just actually guess and check 2 to the 1, 2 to the 2, 2 to the 3 until you get to the right one. All right, how do we write this as a logarithm? Well, the base stays as the base. So the base of the exponent is the base of the logarithm. So I know it's log base 2. The exponent is equal to the logarithm, so the exponent is out here equals, and then the value over here becomes the value that we're taking the logarithm of. Log base 2 of 32 is 5. All right, I would like you to practice the next two on your own. Actually, just practice the next one. I don't know why I have this one down here. Don't do this one right now. That was in the wrong spot. Just try the next one on your own. All right, come back and let's give this one a try. 10 to what power is equal to 1/10,000th? That's such a hard word to say. 1/1000th. Sometimes if you write it as a fraction, maybe it's a little easier to see. Well, 1,000 is 10 cubed, right? So 10 to the negative 3 is going to be equal to 1/1000th. All right, so 10 to the negative 3 is 1/1000th. Let's rewrite this as a logarithm. Well, my base stays my base, log base 10. My exponent is what the logarithm is equal to, so that comes over here, and the value is the value inside the logarithm. Log base 10 of 1/1000th is equal to negative 3. If you wrote log base 10 of 0.001 equals negative 3, that's fine also. All right. Let's talk about, we've gotten pretty good at computing some values. Let's talk about some special logarithms. There are two very special logarithms that we use in science all the time, and they get special notation. They're used so often. The common log has base 10. So if you want to write it all out, you would write it as log base 10 of t. But most of the time, people don't bother to write a base. So if no base is written, that means it's log base 10. And the other base is natural log, which has base e. And if you wanted to write it in our notation, it would be log little e of t. Remember, that's e from compound growth, continuously compounding growth. It's a very important number in the sciences. It's used so often that we actually write that one as ln t. And sometimes people even just say ln of t. That means the natural log or logarithm base e. So exponents we put on e. Right? These are really easy to calculate because they're already in your calculator. So what I'd like you to do is pull up a calculator. You can use the Desmos online calculator. You can use the calculator on your phone. Any scientific calculator will have natural log and base 10 log. And I'd like you to practice computing these values. So pause the video right now and go through and calculate these. All right, I went ahead and calculated these on Desmos. Let's look what I got. So if I typed in log base 10, or just log, and I used this button right here, log of 100, I got 2, and that makes good sense, hopefully, because 10 squared is 100. So we actually probably could have figured that one out on our own. But one maybe we can't figure out is 10 to the what gives me 21. Well, it turns out 10 to the 1.322219295 gives me 21. So actually what this actually means is that if you took 10 to the 1.322219295 power, you'd be pretty close to 21. I mean, there's some pretty close. There's some rounding there, but you'd be pretty close to 21. All right, let's try the next one. This time I use natural log button right here. Natural log of 277 was 5.624, So if you took e and you raised it to this value, you'd get pretty close to 277. And finally, natural log of negative 13. Did you fall for this one? Maybe. Remember, we can't take logs of negative numbers. This guy's no good. D and E. We can't take e to any power to get to negative number, negative 13. So that one does not exist. And I like that this calculator just tells you undefined. Different calculators will tell you different things. Some will say error. I like it says undefined. All right. Let's calculate 3 easy, I say easy ones, but they're not super easy if you're just learning logarithms. But three tricks that we can help us remember. How about 3 trick ones? Number 1, if you have a logarithm where the base is equal to the inside part here, that's always going to be equal to 1. Log base 115 to 115 is 1 because 115 to the 1 equals 115. So no matter what that one is, if the base is equal to what's inside, that's going to give you 1. Number 2 tricky one to keep a lookout for is anytime that there's a 1 inside the logarithm here as the argument. What gives you an output of 1 from an exponent? So we take 23 to what power will get us to 1? Well, anything to the 0th power gets you 1 except for 0. We don't do log base 0. So 23 to the 0 equals 1. So anytime you see a 1 in here, that's going to give you an output value of 0. And one more to watch out for. This is another one. Anytime this guy in here is negative, this one's going to not exist. D and E. So 3 special logarithms to look out for to build your logarithm arsenal. All right, and the last thing I need to talk about in this section is let's revisit talking about exact solutions versus decimal. All the calculations I've done so far, except for the ones where I just said to plug it in and get an approximation in your calculator, were nice whole numbers or nice fractions. They're not going to stay like this. There should be in parentheses there. Most of the time, I'm going to ask you for exact solutions, so I want you to know what I'm talking about. For example, if you are solving an equation, and this is going to come up later in this section, so I just want to hit it now. If you're solving an equation and the answer is log 3, I want you to write down log 3 as your answer. If I ask for an exact solution, log 3 is an exact solution. If you're doing a story problem where you need to get like an estimate, then you can round and give a decimal version, but most of the time, I'm going to ask for the exact solution, so log 3 is exact solution. At this point, you may not be super comfortable with numbers like log 3 as an actual number, but it is an actual number, and you will get more comfortable as time goes by. Another example, natural log of 7 is an exact solution. 1.95 is a rounded version. You can use that for story problems, but if I'm asking for exact solutions, I want to see that natural log of 7, or even log 5 divided by natural log of 4. Again, those are the exact solutions. So you will be having solutions that look like those. All right, well, welcome to logarithms.